Hello everyone. In this video, I want to explain about pointers with two-dimensional array. So we know that already I have explained about the pointer with one-dimensional array. So to understand about the two-dimensional array, first we should understand how that two-dimensional array is stored in the memory. In theoretical discussion, we imagine in that the two-dimensional array can process the data in a rows and column format. That only to understand the students theoretically in books and wherever while we are explaining on board, we are explaining with a number of rows and column. But in real time, the memory cannot store in this corresponding table format. There is no table format memory allocation for array. So it's always they are in a contiguous format. So there we have only dimension 1, dimension 2, dimension 3 like that only. Okay, no? So according to the dimension, there are two dimensions are there. Means what it means that two dimensions. First dimension value, if in case it is a 4, then what could be happen? The four dimension, the dimension value, the first dimension value starting from 0, 1, and end with 3. So like that, the three values we can able to give for the first dimension. Second dimension is become 2, means the values are starting from 0 to 1. Okay, accordingly, we have a index value for every cell. Now, the first, if you are mentioning the two dimensions, the first cell value will become a dimension 0, first dimension, second dimension 0. Next, second index value or second cell value will become a 0 index, and second dimension is become a 1. Next value is become a first dimension 1, second dimension 0. Next will become a first dimension 1, second dimension 1. The next value first dimension is 2, second dimension is 0. Next element index is become a first dimension 2, second dimension 1. Next index value dimension 3, second dimension 0. Like that we have a index values for every element in the two-dimensional array. Accordingly, we have a base address for everyone. Base address nothing but it is a first byte address. First byte is the address of the first element, fourth one, second element, fifth, fourth and fourth, like that we have. Okay. Now, before go to the two-dimensional pointer, two-dimensional array with pointer, we should let me revise about the one-dimension pointer variable first. So in one dimension pointer variable, example, there is a variable like a b of 4. This is an array and a pointer variable p. Now, how we are assigning a pointer variable? That is generally p is equal to b. Why? Because b itself it has a base address of a array. So what is the base address of array? 3000. So directly we are assigning to the p. Now, no need to give a address of operator that I have explained in the video itself. Now, p is equal to p value to the address of first byte. So 3000. Whenever you want to go to the next index. So what is the next index address? Next index address is at 3004. After the next index address is at 3008. After the next index address is becoming 3012. Like that we have a addresses for everyone. Now we want to move from one index to another index. I want to access the value of the second index. Then followed by I want to access the value of third index, and next one is the fourth index I want to access. Then how we can able to access by using the pointer variable? Very simple. Where we have a base address, when you call p, you will get a base address. For that base address, you need to add 1. Means it is not 3001. It increment the address with the size of integer. What is the formula? So generally we can say it is a 3000 plus size of integer. Size of integer. So what is the size of integer? So it is a 4. So like that we can able to add the p plus 4. Means it is a even multiply with the index value. What is the multiply index value? 1. So 1 into size of integer. Then what is the value will become 3000 plus 1 into 4, it is a 4. If you want to access the next value, after the next value, just to increment p plus 1. So p plus 2, what could be happen? The base address 3000 plus 2 into 4. Now 4 is the size of integer. Now it is becoming 3000. It is the its result is on 4. Now its result is becoming 3000 plus 8, which is becoming 3008 index we can able to access, address we can able to access. Like that we can able to move just to add the number, or else we can also use the p plus plus. P plus plus also will increment the address. But meanwhile, it will update the value stored in the pointer variable. So anyone we can able to use. Next, to print the value, simply we have to keep the pointer indirection operator over the this expression. You will get value at p plus 2 index. P plus 2 nothing but 3000 plus 2. It become a 3008. So the value is become a, we print the value as a 30. So this is a process in a one-dimensional array. But how? What are the types of processes are there in a pointer for two-dimensional array? There we have a two basic types are there. Basic types are there. I want to explain the first type. So I just want to remove this discussion. Let me explain about the first type of pointer evaluation for two-dimensional array. So I am declaring the pointer. Some first I am declaring array with 4 and 2. 4 and 2, comma pointer p. Now pointer this is also integer term. Now p is whenever you give a p is equals to a, you cannot get a address directly. So we should also tell about what is the second dimension for this pointer. This is the first type I am explaining. Then we have a two types. I am explaining about the first type. In first type, what could be happen? So p is equals to a means we will get only the one dimension reference. We should also tell about what is the second dimension reference that we can able to give by this format. P of 2. P of 2 we should say now means there are two columns are there. This is a way we need to assign a base address of A to pointer variable P. Then we have an alternate other method that I will explain after this one. The first type I am explaining. We should mention the second dimension. Second dimension we should mention with the pointer. Now assign address of A means A you need to assign. Now there is a pointer variable. Now it store the address of so but it needs to process with dimension. With address only, but it is also process the dimension. Now what could be happen? We store the address of base of 4000. 4000 has been stored. Now we can able to access element one by one. What is the formula? What is the notation we should follow? So very simple. Whenever you are moving from one index to the another index, what you are following? You are following the what you are following like this p plus 0. What you will get? You will get a base address in a one dimension. P plus 2, P plus 1. Second index you will get P plus 2. After the next index you will get like that. To get the value, simply you have to mention the indirection operator. Indirection operator. So here also indirection operator P plus 1. Like that here also. This is for only one dimension. But in two dimension, what is the way or procedure we want to use? In three dimension, you want to go to the index number 0 to 0 or 0, 1 or 1, 0. Wow. The notation, here I am writing the clear notation format. The base address, first we have to take the base address and row value, uh, row value and apply the indirection operator. It is only not enough to access the element. We should also mention the column value or nothing but it is not row and column. It is a dimension 1 plus dimension 2 and I can enclose with every time we are indirection operator. Now this is equals to a of the array of 2 and 1 element. We are reaching to the corresponding element by incrementing the increment p plus 2 plus 1. Okay, so p plus 2, again we should use the indirection operator, plus 1, again we should use the indirection operator. This is the notation to reach the a of 2 and 1 index. Similarly, to reach the 0, 0 index, simply pointer, same pointer of something. You want to reach 0 to 0 now? Very simple. Here you keep 0, here you keep 0. Now which is equals to a of 0 to 0. To reach next any other element. This is the first type of procedure, one by one. Then which is equals to the value you will print a of 1 by 1. Okay. So if you want to reach the address, just to remove the indirection operators. Just to remove the indirection operator, you will get so this is the way we want to access the As one, yeah, one, nothing but p plus one and plus one. So finally, we will reach the element everywhere. Okay. This is the first type. There we have a simple program. There we have a simple program. Let's also execute the program. This is the way we are accessing that base address place. This is a one alternate process that I will explain. The program here we have. Let's execute this program. Now, what is the notation we have used? We have used this kind of notation. Okay. So this is the notation we followed. What is this notation? P plus first dimension plus second dimension. We are keeping in a pointer so that you will get able to access the value at this location. Okay, so this is the first model. The next, let us go to the second one. Mostly we are using this second type, only, not first type, because theoretically we are analyzing every time the two dimension is a rows and column. So to understand that rows and column, we should go to the second type of procedure to process the pointer value on two dimension. Okay, in second procedure, first it is also a different kind of concept. What is the example we have in the PPT? The PPT example is a 2 into 3 matrix. Okay, 2 by 3 matrix. So that let me initialize and run the 2 by 3 matrix. So here I'm declaring a 1 2 by 3 matrix into AR 2 and by 3 matrix. Okay. Now for that I'm also declaring a one pointer variable p. Now p is equals to p should be with a base address directly. So that is mean that a address of a of 0 and 0 address we should assign. We are not mentioning the any dimension over here. Purely the concept will move based on the addresses. Okay, purely we move on the addresses only, and that also addresses, but the analyzation will goes with a address itself. So this first index, second index, 2 into 3, nothing but total 6 index. 3, 4, 5, 6, like that we have indexes. The first index value in case it is a 2000. The next index value is become a 2004. And after the next is become a 2008. Like that we have. 2008, 2012, next one is a 2016, right? 2020. 2020, how many we have? 1, 2, 3, and the total. Then we have a 6 indexes going to be. Now, first base address has been be allocated. So whenever you allocate the base address, directly only the 0, 0, 0 address value has been stored in the pointer variable. Now, pointer variable p, which to the address of 2000. 2000. Now this is pointing to the, where it is pointing, this point to the base address of the array. The values are, according to this explanation, values are 1, 2, 3, 4, 5, 6. So now the value of this location is a 1, 2, 3, 4, like that. We have the values. Now we want to process the corresponding index. How we can able to process? Here we have a small calculation. To access any index value, first we should take the base value. Base place, the columns are referred by this by. Rows are something like a referred by a the example. Okay, now this example is completely processed with the rows and column wise. Let me explain the program here. Here what could be happen? See, so this is a assigning of address to a pointer variable. To print the base address, we can directly print here, or else we can able to directly print from the pointer variable. Okay. Then followed by we want to reach every element. Two dimension array can able to reach by using a nested for loop. Now here I is equal to refer to the rows. What are the rows? How many rows we have? Two rows are there because according to the our analysis we have two rows and columns. We have three columns. So column values are three. Okay, now this is a column variable. This is a row variable. Now we want to travel over the corresponding array. Okay, I less than we know that we are initially at first row. Okay, first row and first column, and we want to access the element accordingly by using this principle. This principle is very important. Whenever you are going through this process, we should follow this kind of notation. The previous one is a different one, and this one is a different one. Okay, no? So we can sort the element. We can by using this kind of we can sort the element. We can sum of elements. All the things we can able to do. Now I will explain what is this notation. How we can able to process with that notation. Now you can imagine the program where we have a number of rows are two. I is equals to two means the number of rows are two. Rows are two. Columns are three. We are referring with a I value and we are referring the column with a j value. Okay. Let's process this one. When in the first iteration, what happened? In the first iteration, obviously we know that first iteration I value is equal to 0 and j also will equal to 0. What is the principle we are following? The principle is a base address place first dimension, or it is a I value into columns into columns into columns plus then after second dimension. This is our formula. This way you will get address. If you keep an indirection operator, you will get a value. So these are principle. Let's implement in this. So when I is equal to 0, j is equal to 0, means it is a 0 0 column, 0 0 cell. What could be happening? What is the base address in case it is a 2000? In case it is a 2000, now 2000 plus 2000 plus. How many columns are there? What is the I value? 0. How many columns are there? Columns are 3. Columns are 3. Now place 0. Now what is this value? It is become a 2000 only. Nothing much is a 2000 address. To get the value, apply indirection operator. Apply indirection operator, you will get the value. Okay. Value at this location. What is the value at this location? The value at this location is something like a 1 will be print. 1 will be print. 1 will be print. Very clearly you have to focus on whenever I want to reach the next element. How to reach the next element? To reach the next element, obviously in the second iteration, what is I value? I value is become 0 itself because it is outer for loop. J value is become 1. The next iteration. Means here we have a 1. Here means here it is a 1. 1 nothing but it is become a 2000 plus 1. It's not a 2001, it's a 2000 plus 1. 2000 plus 1. It's an incrementing of size of integer. So it become, I could write over here. It means 2000 plus size of integer. Always the incrementing of address will reflect with the size of that corresponding data type. So that is become a 1 into size of integer. It is equal to 2004. 2004. Subsequently, whenever I is equals to 0 and j is equals to 2, then what could be happen? So here same thing, the same procedure we should follow. Same procedure. Base address is a 2000 according to the P. Value is become a 0. Number of columns are 0 to 3. J value is a 3. Now it seems like a 2000 plus 2. What do you mean by the 2000 plus 2? It is increment the address. Means it is a 2000 plus size of integer. 2 into size of integer. Now it is become 2000 plus 8. 2000 plus 8. Size of integer is a 4 now. When size of integer is 4, now I am expanding. Size of integer is a 4. Now it is becoming 2008. So 2008 value is equals to address value is equals to will become a something like a 2 or 3. Okay, like that. Okay. Okay. Next, in similar way, I want to reach the whenever I also increment whenever I is equals to something like a 1 and j is equals to something like a 2. We want to access that element. I is equals to 1, j is equals to 2. So according to here 0 0 0 1, let's try the indexes. Now what you will get? I value is equals to 1, j value is equals to 2. Now what it is going to be happen? 2000 plus the base address plus 1 into 3 plus 5. 1 into 3 plus 2, 5. Okay. Which means 2000 plus 5. 2000 plus 5. It become a 2000 plus 5 into 4. It become a 2020. It is the last index. Last index value 1, 2. Last index value 1, 2. What is the first index value? First index value is a 0, 0. Second index value is a 0, 1. Next index value 0, 2. Next index value 1, 0. Next index value 1, 1. Next index value 1, 2. Like that, whenever you want to access you want to, what is the address? 2020. Is whenever you want to access, whenever I is equals to 1, j is equals to value, it is becoming 2020. The address, the value at this location is become a something like a 6. The value at this location is something like a 6. Okay. Okay. So this is in this way we can able to access the corresponding element by using this kind of notation. What is the notation we are following? If you remember this the notation format. Okay, let's execute this code also. You will get now with respect to this code, what could be happen? So here we are running the for loop, outer for loop, and inner for loop. First, you should also understand the iterative statements, outer and inner for loop, followed by we are running only one printf statement for every time, but the notation is a pointer, the corresponding pointer I into column plus j. Okay, so this is the notation. Next, also we have a one other alternate method. So this is the evaluation process. When I is equal to j is equal to 0, what is the expression will become? And expression final output. This is becoming final output. And whenever it is a pointer plus 0, it could be accessed the zeroth number, 0 dimension, first element base address. It is becoming 2000. After you evaluating, it is becoming pointer plus 1. You can also write the notation in this format. Directly, you can also write this notation format. To understand the columns and rows, we are basically following this. But after this evaluating, you will get this kind of notation only. But if you write directly, you don't understand where you are going. You don't understand. You should directly write this one. You should express everything in a I comma j format into multiply with c. And finally, you will get again the value in this kind of notation. Okay. From there, the values are moving from one index to another index in the address increment. Address increment with 0, no change. Address increment by 1, it is increment by the 4 byte. Address increment by the 2, increment the 8 bytes. Like that with the base address. What is this here? PTR? PTR always it is become a base address. Okay. Next one more alternate method. So same way, this is the notation we are following. No? This is the notation we are following. Okay. Even after you are evaluating this expression, the notation will convert into this format only. But here we clearly understand. Whenever you write this expression, you clearly understand what is the row value, what is the column value, what is the I value, what is the j value. Clearly you will get understand. But In the computer, after executing this expression, the expression will convert into this notation format only. So we can also process the data by using this notation directly. So for that, we have one alternate method. This is a method we have. Okay. Total to understand this one, actually, how many cells we have, how many elements are there in the corresponding array. So to understand that, we should define how many elements are there in this corresponding array. 2 into 3. If anything is declared in something like a of 4 into 3, then how many elements are there? 4 into 3. There will be a 12 elements. If the array is declared as a of 2 by 3, then how many elements are there? It is a 2 into 3, 6 elements are there. So first we should find out the number of elements. How do you get the number of elements? Multiply number of rows and columns. I could say it is a number of rows multiply with number of columns. Number of columns. Now it is the rows are 3 and columns are rows are 4, columns are 3. So it is becoming 12. Here the rows are 2 and columns are 3. So it is becoming 2 into 3, 6, like that. So first we are identifying total how many elements are there, and accordingly you move from index by index with only the address increment. It's the best alternate method, which has become more easy than previous all programs. But we should calculate for here only. We can only run with a single dimension array because there is no two dimension concept in the real memory. We have a linear storage or a continuous memory only. We can run the same two, even it is a two dimension. By using the pointer, we can run the program with only a single for loop. So for that, we have an alternate method. What we are doing here, we are defining the 2 by 3 matrix, nothing but how many elements, 2 into 3, 6 elements are there. Okay, 6 elements. We are assigning pointer with a base address of a first index. Okay, that we should do. Then after we are calling a one function, total is equal to sum of array elements. The program is about the sum of array elements. Okay, now control will transfer to here, control will transfer to here. Now we are running this program with only single array. We are traveling over the array with one index by another index because it is only one dimensional. When it's the two dimensional, in real time, the compiler stores the allocate the memory in a continuous or linear allocation. First, we need to find out how many cells are there, how many total number of cells are there, how many elements are there. Multiply rows by column. We know that rows are 2, columns are 3, 2 into 3. So total number of elements are 6 elements. 6 element, and increment every time, and we can go by so that let me explain the code. Let's execute and discuss. Here, what is this code? This is our code. In this code, what actually we are doing? Here for loop, for every time adding with pointer with I. What is the first value? What is the first point of base address? 2000. 2000 plus 5. I nothing but initially in the first iteration it is a 0. The next iteration 2000 plus I will become 1. Okay, next iteration it will become 2000 plus I will become 2. Next iteration 2000 plus 3, like that. We are moving. How many total iterations are in total 6? Nothing but 5 iterations should be done. Next iteration, what happened? 2000 plus 4. Last iteration is a 2000 plus 5. So these are our iteration. For every time we are adding the value. So what could be happen? Whenever 2000 is 2000 plus 0, nothing but 2000 plus size 0 into size of integer. Next to 2001, nothing but 2000 plus 1 into same formula for every time. Size of integer. Size of integer. How much of size? It become a 4 size. So it is becoming 2000 plus 4. It's become a 2004. Become 2004 simply. Okay. In similar way, we are going to be do the next calculation. So 2000 plus 2. What could be happen? 2000 plus 2 into size of integer. that integer is a 4. 4 plus 2, 8. Like that, we can able to travel index by index. Just we are taking the base address plus adding of number. Here, there is no concept of rows and columns in this code. There is no concept of rows and columns. Rows and columns are multiplied and they convert into a single value. This value. What is the value? What do you mean by this one? I less than 6 directly. There is no row and column. Currently, we are traveling in a particular linear stored array memory 2000, 2004, 2008, 2012, 2016, 2000. Like linearly, we are moving from one to another index. We are not process the data with a rows and column indirectly. Okay, now there is no and row or row and column adding subtraction like that. So this is another alternate method and easy method, but it is not suitable for every example. Whenever you are crossing the matrix operation, transposition of matrix, reverse of multiplication of matrix, addition of matrix, that time this kind of concept cannot be make you very well understand. Okay. So these are the basic example on the two-dimensional matrix. In the next video, I will explain more strings.